Alright, so we're going to skip a couple of sections and come back to them, but this is some stuff for the juniors who are taking the ACT next week. The law of sines, which might potentially be on the ACT, so it might be good to know some of these things. So if you guys remember, back in Chapter 8 we talked about the trigonomic functions and how we use the trigonomic function ratios trigonomic ratios to find we use the trigonomic functions to find ratios of a right triangle. Now at the time I told you that they were only for right triangles. Now I gotta break it to you and tell you that you can actually use the trigonomic functions for obtuse angles. So and we can use calculators for this. So the reason right here of why you can do that, so first of all, tangent of 150 degrees. Now back in chapter 8, we would solve this first by, we would draw an angle on a coordinate plane, and the angle would rotate 150 degrees. So that would be about right here. Now we know that that creates a 30-degree angle. The reference angle is 30 degrees. So if we drew a 30-degree triangle, right triangle, it would give us the sides of 1, 2, square root of 3. This would be negative. Okay. Now, tangent of 150 degrees in this situation would be 1 over negative square root of 3. And then if you rationalize the denominator, that becomes negative square root of 3 over 3. So if we punch that into a calculator, so negative there we go, negative square root of 3 divided by 3, and we get negative 5.7735. So that's whenever we found we found that by we found tangent of negative or 150 degrees, and that's equal to negative square root of 3 over 3, and we did that by using its reference angle and a coordinate plane. However, if I just take tangent of 150 degrees, you notice that I get the same exact number. So this is why so before I told you that you couldn't, just so that you wouldn't use your calculator for this, but you actually can use your calculator. This is just the method of without using a calculator. But yeah, so this is equal to approximately negative 0.577. Okay. So you can do the rest right here. Just in your calculator, you're able to punch these into your calculator. So sine of 120, cosine of 95. So you can use your calculator for that. Just remember, of course, go to your mode and make sure that you are in degrees and not radians. Okay. Now the area of a triangle. So there are formulas that we can use to find areas of any triangle. So this is for any triangle. So for any triangle, you can use these formulas, okay? There are three ways that you could find the area of any triangle. Okay, so the first one is area. I'm just going to put in A for area. Actually, I'm not, because that might get confusing. I'm going to do area. Area is equal to 1/2 of BC times by sine of A. Or area is equal to 1/2 of AC times sine of angle B. Or area is equal to 1/2 of AB times sine of C. So what we should take away from this is that if we take half, so we're taking the product of two sides. So here you're taking the product of BC, in cutting it in half, multiplying it by sine of A. So notice here that you have B and C, and sine of A. So basically, how I like to look at it is that you're using one of A, B, and C. So you're using two sides. So in this case, those two sides are B and C, but then you're using the angle that is not opposite, okay? So C is the side opposite from angle C. Side B is the side opposite from angle B. Okay, so if you use these two sides, then you have to use the angle that you're not using the opposite side from. So if I were to use one of the other two equations, let's say I take side A and side B. So side A is opposite from angle A, side B is opposite from angle B, so I'm not using this angle, angle C, so that's what I'm going to use sine A of, or sine C. So again, half of AB times sine of C, or it's half of AC sine of B. Okay, so let's use this right here in this example. So in example 2, first of all, it's not going to give you all of your sides, right? So we are missing the side opposite from angle A. We want to find the area of this triangle. So notice that we have the side opposite from B of angle B, and we have the side opposite from angle C. So that means that I want to use this first one right here. So I know that the area of this triangle is equal to 1/2, okay, side opposite from B, which is 17. So 17 times by the side opposite from angle C, which is 19. And that's going to be multiplied by sine of angle A. So sine of 135 degrees. So let's go ahead and punch that in here. So it depends on the order that you do it, but let's do 1 divided by 2, parenthesis, 17, and then another parenthesis, 19, and then sine of 135 degrees. And I get 114, we'll round up right there, 114.2. 114.2. There you go. However many units this is, 114.2 units, that's the area of, I guess we should say square units because it's area. So 114.2 square units for the area of that triangle. Okay. Alright, now let's talk about the law of sines. So this might be what's important for you potentially on the ACT, is to know the law of sines. So you can use the law of sines to solve triangles. Now, the term solve triangles, if you remember back from 8.1, solve triangles basically just means to find all sides and angles, so all side lengths and angles. Okay, so here's the law of sines. So you can use the law of sines, use it to solve triangles when two angles and the length of any side are known. So that means whenever you know angle angle side or angle side angle. Right. Okay. Or when the lengths of two sides and an angle opposite one of the two sides are known. So that would mean side angle. Okay, so you can use the law of sines. So again, whenever you have, so in this case, an angle, or a side. So that's an angle, or a side. Or you could do an angle, and a side. Or an angle, and a side. So basically, anytime you know two angles and the non-included side. When you have two angles and the non-included side. So here would be, if you know this angle and this angle, if you have those two angles and the non-included side, like that, then you can use it. Or, whenever you know, whenever you have a side, and then the angle. So side, and angle. So when the lengths of two sides and an angle opposite to one of those sides. So you see how if I know side A, and here if I know side B, if I also know angle A, or if I also know angle B, then I could use the law of sines. Okay, and let's go through several examples of these. So solving whenever we know an angle side or an angle side angle. Oh, I should also probably show you what the law of sines is. So the law of sines says, let me try and make a little bit more space right here. This is the law of sines. It says that sine of angle A divided by A is equal to sine of angle B divided by B is equal to sine of angle C divided by C. Or you could write it as its inverse, which would be A divided by sine of angle A is equal to B divided by sine of angle B is equal to C divided by sine of angle C. So pretty much the side lengths, so the sine of an angle, the ratio of the sine of the angle and the side opposite are always equivalent. I guess you could say that, the ratios. So let's use this rule to help us. So in angle ABC, we want to use this. So first of all, let's notice what sides and angles we have. So notice here we have a side, and we have an angle, and we have an angle. So we have two angles, and this angle is not included between this side length. Sorry, the side length 15 is not included between these two angles. So that means we have an angle, and a side. So we can use the law of sines here. And we're trying to solve the triangle, which means we need to find all its parts. So we need to find A, we need to find C, and we need to find angle A. Okay. So first of all, you can use the sum theorem, because we know that the sum of all the angles in a triangle is 180 degrees. So I can take 180, I can subtract 107 and subtract 25, and I get 48 as my missing angle. So this is 48 degrees. Alright, so angle A is 48 degrees. Now we need to find side length A and side length C. So let's use these law of sine. So I'm missing side length A, so I'm going to want to use this one right here. I'm missing side length B, so I'm going to need this one right here. And I know side length C, so I'm still probably going to want to use this one right here. These are all equivalent, so this is how you can set it up. So let's say we use sine of angle A, which we know is 48 degrees. And this divided by its side length, so the side opposite to it, A, this is equivalent to sine of angle C, which is 107, divided by, actually I don't want to use this one because I don't know angle C, so I want to use angle B because I know its side length. So sine of 25 degrees divided by its side opposite, which is 15. So now I have an equation right here with an unknown variable, A. So I can use that to solve this equation. This is something that you might have learned a long time ago called cross multiplication. But if you have two fractions in an equation, then you can use this method of cross multiplication to solve. So cross multiplication means that A times by sine of 25 is equal to 15 sine of 48. So now to solve for A, I just have to divide by sine of 25. So I know A is equal to 15 sine of 48 divided by sine of 25. Okay, so let's go ahead and use that. So 15 sine of 48 divided by sine of 25. And I get 26.4. So I know that this right here, so A is equal to 26.4. Okay. Now I still need to find side length of C. So I'm going to use, again, the same thing, but I'm going to use sine of B and sine of C. So sine of 25, which is angle B, so that divided by 15 I could write as equal to sine of 107 over C. I can use the same method of cross multiplication. So I know that C sine of 25 is equal to 15 sine of 107. Divide by sine of 25. So C is equal to 15 sine of 107 divided by sine of 25. So just punch that into your calculator. So 15 sine of 107 divided by sine of 25. So it's 33.9. Okay, so this is equal to, oops, wrong one, equal to 33.9. Okay, so the triangle is solved. Alright, now I'm going to move on, but I'd recommend that you guys try this one as well. So notice the side lengths and the angles that we know. We know this angle right here, we know this angle right here, and we know this side right here. So that's an angle side angle, meaning that the side is included between the two angles. So you should be able to use the law of sine to help you solve this triangle. Okay, now I'm going to come down here to this next example. Okay, so this is solving with SSA. Now, solving with SSA can be tricky sometimes, and I'll show you why. Because sometimes you can have multiple solutions, sometimes you can have no solutions. And sometimes you can have one solution possible. Okay, so again, we're using obtuse angles. So notice here, this angle right here was obtuse. this angle up here was obtuse. So this is an obtuse angle right here. So I'll show you in these upcoming examples of the difference of finding one no and two solutions. So this one is one solution. Okay, so there's only going to be one solution. Okay, so so we can use SSA. We can use SSA if we have the right things. So we here have a side, and one of the angles opposite to the known side lengths. So we can use SSA here. So using that, we could say, let's set up a law of sines formula. So I know angle A and the side opposite from it. So let's start there. I know sine of 115 is divided by 20 is equal to a ratio. So it could be sine of B over side length B, or sine of C divided by sine of C. So let's start with well, first of all, we have to solve for one of the angles. So let's just pick one of these ones as let's say B, because I don't know the angle for B, but I know the side length across from B, as opposed to C. I don't know angle C, and I don't know the side length across from C. So let's use B. So sine of B sine of B divided by 11. Okay. So what I could do here is I can cross multiply. So then it becomes 11 sine of 115 divided by 20 equal to sine of B. Okay. Now we're going to introduce a new function that we haven't talked about, and if you've noticed on your calculators, if you look at your sine, cosine, and tangent, you see how in the top left you see the sine of -1, cosine of -1, tangent of -1. So we call these arc sines, arc cosines, and arc tangents. And what they do is they undo sine functions. So you notice here that I have sine of B. So I need to get rid of the sine. I need to get rid of sine. So in order to do this, I am going to, let me write it right here as sine of B equal to 11 sine of 115 divided by 20. But what I'm going to do here is I'm going to do sine, arc sine of both sides. Okay, now as I do that, this will cancel, so I'm left with B is equal to 11, or is equal to arc sine of 11 sine of 115 divided by 20. Okay, so here's how I'm going to do that. First of all, I'm going to put in 11 sine of 115, divide that by 20, and then I'm going to do second sine of my answer, and that's how I find that angle. So 29.9. So B is equal to 29.9. So now you know how to use those sine, arc sines, arc trigonometric functions. That's how you use them. You use them to find angles, to undo trigonometric functions. So let's see if we can do that again here. So I know that C is equal to 29.9. Okay. Now that I know that, I can use law of sines and I can find, or I can, well, I need to find either angle B or side length C. Okay, so let's find side length C. So I know I know sine of 115 over 20. So using angle A and side length A, this is equal to, we could do C, so sine of 29.9 divided by C. I can use cross multiplication. So I know that C sine of 115 is equal to 20 sine of 29.9 divided by sine of 115 divided by sine of 115. So C is equal to 20 sine of 29.9 divided by sine of 115. So 20 sine of 29.9, and that's being divided by sine of 115. And I get 38. Oops, I accidentally didn't do that one. 1 second. Let me come back up here. I forgot one of my ones. 115, 42. Okay. Right. So sine of, I need to make sure that I did this. I might not have, because C should not be that. Let me set up my equation again. Sorry, bear with me, guys. So I can use sine of 115 divided by 20. This is equivalent to, we can use C, which is sine of 29.9 divided by C, cross multiply, so C sine of 115 is equal to 20 sine of that's why, because I wrote it as the wrong one. B is equal to 29.9. So I totally wrote that wrong. Sorry about that. So what I need to do is find angle C first. So I can just use the angle sum theorem. So I can do 180 minus 115 minus 29.9, and I get 35.1. So angle C is equal to 35.1. Okay, now I can use it. So sine of 115 divided by 20 is equal to sine of angle C, which we now know is 35.1, divided by C. Cross multiply, so I get C sine of 115 equal to 20 sine of 35.1 divided by sine of 115 divided by sine of 115. So C is equal to 20 sine of 35.1 divided by sine of 115. Okay. So we get 20 sine of 35.1 divided by sine of 115. And I get 12.7. So C, side C, is equal to 12.7. Okay. So that's getting one solution for all these side lengths and angles. Okay, now let's look at something that has no solutions. So this was an example of an obtuse triangle that you can only create one triangle with. Okay, so pretty much how this happens is so basically, let's say we have an obtuse triangle. So like the one right here. I'm gonna just erase this. Hopefully you guys have that written down. If not, just pause the video and write down. But if I draw, say, a circle, okay, let's say I draw a circle, try and make that even as possible. So let's say that this circle right here is my side length of C. Okay, so notice that here with a side length of C, or I guess I should do it of A. So let's say A. Notice that with this side length and this triangle, I can only make one triangle with this side length as 11. Okay, so basically just as in this triangle, I can, and this side length right here as 11. If I were to try and make another triangle, it wouldn't work. So that's why I only have one solution. However, there are other obtuse triangles that you could actually make more than one triangle with, and then there's even some triangles that you can't make any triangle with. So, for example, let's say that you have, let's make an angle right here, and an angle right here. So let's say that I have a circle right here. Make it go just a little bit more. Okay, right here. So if I have this obtuse, if I try and make an obtuse triangle here, notice that I can't make an obtuse triangle. I can't make a triangle unless it's perpendicular right there. That's the only length. If I use this circle right here, that's the only time that I could do such a thing. So basically, if this side right here ends up being shorter than this length right here that makes it 90 degrees, then I don't end up with a triangle. So that's going to be the issue that we run in with over here, is that if we try and compose this triangle right here in example 5, so if we have triangle ABC, so let's make a triangle. Okay, so let's call this angle A, which is 51. So angle A. And then let's say that this side length right here is 3.5, which is A. Okay, and then let's say that oh, whoops, sorry, it has to be B. This one has to be 5 because angle A has to be, or side length A has to be opposite of angle A. So let's say that angle B is somewhere over there. And so this one would be 5, and then we'll call this angle C right here. So then this angle we'll say is 3.5. But if this is the case, so if you have a side length across from an angle, then that's shorter than the other one, so 3.5 and 5. So basically, this side length, because it's smaller, you can't create a triangle out of this information that's given, because it's too small. So because the side length is too small, you can't make a triangle in any sort of way, pretty much. So if given this angle and the side length right there, angle 5, I can't create another triangle right there, no matter where I move that side right here. So no matter if I have a radius of 3.5, I can't hit the side length of AB, thus I can't create a triangle. So in this case, it's not possible to even draw this angle and this side lengths and the side lengths given in order to make a triangle. Okay, so that's why it's sometimes with your given information you can't even compose or make up a triangle. So in this case we have no solution. So now let's talk about whenever we have a triangle with two solutions. So this is what happens when you have a triangle with two solutions. So if we have side lengths like we have here, so this is angle 40 and side lengths 13 and 16. Now, if I make a radius right there of 13 at the point C, so notice if I take a 13 radius, make this circle, notice that I could make another triangle right there. I could make another triangle that has side length 16, side length 13, and side length AB. I can compose another triangle with those given side lengths, like that. So this is angle A, C, and B. This is still angle 40 right there. So that angle right there is still 40 degrees. This side length here is still 16, and this side length here is 13. So given this information, I could have two triangles, which is how I can get two different set of solutions, okay? So, in that case, you'd have to solve both triangles, so that's how you can get two solutions. So, now I think at this point it's pretty clear how you can get to those solutions. You just use the sine of, you can use so this is an SSA, so I'll find one of them, but I know sine of A, which is 40 degrees, divided by 13 is equal to, we could say sine of B divided by 16. So if you cross multiply, you get 16 sine of 40 is equal to 13 sine of B. So we can divide by 13, or just divide by 13. So sine of B is equal to 16 sine of 40 divided by 13. Now I need to get B by itself, so I'm going to do arc sine on both sides. So B is equal to arc sine of 16 sine of 40 divided by 13. So that's going to be 16 sine of 40 divided by 13, and then I'm going to do arc sine of that value, and I'm going to get 52.3. So B is equal to 52.3 degrees. And you could find the remaining angle right there by using the sum theorem, and then you can use the law of sines again to find the side opposite from angle C. And then you just use the same methods here. It's just that your angle for angle C and your side length for side length C will be different, okay? And that's how you get two sets of solutions. Okay, so that should pretty much do it for law of sines. Really, I think the equations are pretty easy. You can set them up how you want. You can set them up like how it is over here or how it is over here. Doesn't really matter. Same thing. And then just be aware of how you set them up. Sometimes if you set them up, there might not be any solutions. Now, if you look at the key on the, I'll probably post, well, I won't post the key for the homework, but I'll probably post something for the homework that gives you a heads up on what to be aware of. So what questions might have no solutions, one solutions, and two solutions, just so you don't get too confused, okay? So just keep an eye out for that. I'll probably upload something for you on Canvas for that. And if there are any other questions, of course, feel free to come in and see me.